All right.
Professor, you're muted.
Right. Yes. All right. Thank you. Yes, I was totally muted. Thank you. So I didn't hear. So hello. Yes. Hello. Okay. Let's do hello. Yes. Hello. Hello, Raheli. Hello, Kat. Sorry. Wait. Yes. Hello, Raheli. Hello, Soha. Hello, Johandra.
Good morning. Thank you. Good morning, Daniel. Thank you. I mean, hi. And good morning, Zitlali. Good morning. Good morning, David. Wow, you guys are fast. This is awesome. Hold on, I'm catching up. So I said, Daniel, Zitlali. Good morning, Ashley. Good morning, Michelle. Good morning. I'm fine. Thank you. How are you? Even though don't answer that yet. Actually, you can answer. I don't even know why I do that. Wait, sorry. Who was that? Molly. Yes. Good morning, Molly. Good morning, Darina. Good morning, Amarani, which I'm still, okay, I'm going to admit right now, still not pronouncing right. So please correct me right now or in the chat or something. I know I'm not doing it right.
Amarani.
Say it one more time. I'm sorry.
Amarani.
Oh, Amarani. I'm sorry. Okay. Thank you for saying that. I'm so sorry. We're hopefully you're going to take 204 and we'll have it right by then. But Amarani, that makes total sense. Okay. Yes. Yaverbaum. Amarani. Right. Okay. Thank you. I'm sorry to do that. Okay. Where are we now? Amarani. Right. Okay. Sorry. Good morning, Luna. Oh, I have to say something about Luna in a second, or at least about the moon. Good morning, Alyssa. And good morning, everybody else. And I know I'm running a little late. Sorry, or running late in many ways, but we have much to provide today. I'm behind you guys. I've been owing you. The debt will be paid today. It's a level. Oh, wait, more people coming in. Sorry. You know, the less I have to say, the faster I talk. It's really weird. Hold on. I said good morning. Wait, someone just came. Sorry. What's going on here? Is anybody in the waiting room? There's a message in the waiting room. What? Okay, no, maybe I think that's everybody. Wait, someone is in the waiting room? Oh. Sorry. Okay. I think they're updating Zoom and some of the notifications are different. Okay. Rolling. Good morning. We have much to do. Okay. Right. First of all, oh, no. Okay. All right. Much. Do one quick thing that Luna just reminded me, or the existence of Luna just reminded me. It's a new moon today. Oh, yeah. Speaking of which, it's a. Oh. Sorry. So sorry. Hang on. Okay. Oh, good morning, Nikaya. Thank you. Good morning, Nikaya. And wait, and there's someone else too. And good morning, Jennifer. Yes. Okay. Good morning, Jennifer. Good morning, Nikaya. Good morning. Okay. It is a new moon today. It is a very quick, just because I actually really do care about the moon and astronomy and stuff like that. You might remember from the beginning of the class, like physics is built from astronomy. Like we learn about motion on Earth from first looking at motion in outer space. It's all very interesting. I love astronomy. I particularly love the moon. So just quick thing about the phases of the moon. It's a new moon today. That means like you don't see anything, right? It's like about to start growing in its cycle again. It'll become half, a waxing half, which is sometimes called a first quarter, then it'll become full. Well, excuse me, it'll become a crescent, then it'll become half, then it'll be 3/4, which is often called gibbous. Hold on, someone else is coming in. Not gibbon, it's a monkey. A 3/4 moon is called gibbous, a monkey is called gibbon. Anyway, then it becomes full, and then it starts shrinking again, or what we call waning. So it goes down to a waning gibbous, and then a waning half, which people call a 3/4 moon, and then goes back to nothing. I'm saying this quick because obviously, like, this is not on your exam. This is not anything you need to know, but it's nice to get comfortable with. But so the moon goes through these phases, right? Not because it really does, but because it does to our eyes, because the moon does not make its own light. It only reflects the light of the sun to our eyes. All fascinating. Like, I love this stuff. Anybody who ever wants to do a project on it, let's talk. I've got books on it, blah, blah. But what I'm getting at right now is that, many historical calendars are based on the sun, and many other historical calendars are based on the moon. Our modern calendar attempts to reconcile both of those cycles, which is kind of a mess. But in ancient lunar calendars, such as the Hebrew calendar or the Muslim calendar or the ancient Greek or Roman calendars, those are all lunar calendars. A full moon is called Ides. Like, the full moon is called Ides because Ides means middle or half, and a full moon is halfway through its whole cycle of waxing, 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 and then waning back. I'm just going to say this quickly. So if you ever read, like, Julius Caesar by Shakespeare, like in an English class in high school or something, you might remember this whole beware the Ides of March. That's supposed to mean beware the middle of March, meaning the full moon of the month of March. I don't know if that's familiar or not, but anyway, Ides means full. Nons means a half moon. Okay, this is how we used to measure time. They didn't have like the 13th or the 15th. It was like, you could be like one day before the Ides or one day after, et cetera, et cetera. So Ides meant the middle of the month, the full moon. Nons, which is where we get the word noon from, meant meant a quarter of the way, a half moon. And calends, this is the part that's sort of worth knowing. Calends, K-A-L-E-N-D-S, means new moon. Okay, it's where we get the word calendar from. Calends refers to the new moon. What it actually means in Greek, I just think this is worth knowing. It's sort of interesting. Calends actually means to account for. Calends is accounting, like accounting. So the whole idea is a calendar is something that's accounting for time. We measure time and account for the phases of the moon. And a calendar, which the Greeks didn't have, calendars were invented way later, but a calendar is a method by which we account for time. But time is money. Money is time. Like, even the Greeks knew you collect rent, for example, at the beginning of the lunar cycle every month. Like, that this is an ancient tradition, that you pay your debts, you collect rent, you pay your electric bill or whatever the equivalent was then. You account for money in step with accounting for time. That's what a calendar is really meant to be about in the first place. So a calendar is an accounting device. The new moon is called calends. But anyway, so happy calends today. In principle, that should mean that you give me money or I give you money or something. In fact, I'll say this also really quickly. When I used to teach super little kids a long, long time ago, like when I used to teach 5th graders and 3rd graders, and I tried to tell them this, and we really did study the moon and stuff like that, like in a 5th grade way, I told them, like, calends means it's the beginning. We're supposed to account today. We're supposed to reconcile our accounts. So really, I just sort of dumbly and jokingly said, like, you guys should, like, give me candy today. And then this one smart girl immediately in the class said, no, you should give us candy today. And I was like, right, good point. I just walked into that one. And for years, then I started this tradition where at the beginning of the lunar month, every year, I'd walk around with a basket of candy and give it to all the little kids. And I even did that at John Jay for a while. Like, even with college kids, I used to give out candy at the beginning of the month. Now, if you were here right now, I would love to be giving you all candy. I can't do that. I mean, I guess but I can't do it through Zoom. I feel so bad. I can only talk about it and make you hungry. The next best thing I can do, instead of giving you candy today, is give you the long overdue, much awaited solutions that you need to this practice midterm. That's what we're going to talk about today, the solutions. Okay. It's not quite as fun as candy, but in desperate times, maybe it's better. I know I'm babbling fast for a change. we're going to start talking about these solutions to the practice midterm. In fact, let me back up and talk about the midterm. I got behind. I apologize. I got confused during break. I got sort of wrapped up in some other classes that were deep in the exams right then, and I apologize. Now it's your turn. Like now, they're done. We're in the exam phase now, but I know I created some confusion or lack of clarity. So let me slow down and back up and say because I even got a couple of calls from some of you this weekend, which is totally fair. Like the exam was originally supposed to be like happening right now. Last week, because I didn't give you solutions fast enough or as fast as I promised, and because there was still concern and confusion, we postponed the exam. I think all of you know that at this point, but let's be super clear. I did postpone the exam. I think I updated it in Google Classroom. Oh, someone's here. Sorry, hold on. Just to be clear, and I'm going to try to be even more clear about this in Google Classroom. I just want to slow down now and be clear about where we are. What I believe, and I think right now it says it correctly in Google Classroom, is that we're going to spend the next 2 days really preparing for this exam together. The next 2 class days. The exam will be posted this Thursday, I think we said, at 8 p.m. by 8 p.m., which usually means 7:45, to be honest. I will post the take-home midterm exam this Thursday. And again, please do stop me or chat at me if any of this is new info, if this is confusing information or contradictory information. But I believe that we are saying that as of this coming Thursday night, I post the exam to all of you. Then it's due. Then you have the full weekend, whatever, to do it. And then you submit it to me right before class a week from today. Okay, and we are strict about that deadline. I'll talk about that again. But just to review the logistics, I'm going to post the actual thing this Thursday night at 8. You have the full weekend to do it. You have infinite resources at your disposal you are allowed to go on the web. You're allowed to look at my solutions. You're allowed to talk to other people, blah, blah. The exam, but then you turn in all of your work, the whole thing in a neat, organized, proud, clear way. You turn in one big document with all your solutions right before class a week from today, and then you show up to class. The exam that will be posted this Thursday will be extremely similar to the practice one that you have in your possession that I'm going to start talking about more directly today. It will be extremely similar. There will be some differences, such as your exam will be shorter. Like it'll be taken from this practice exam, i.e. if you can rock everything on this practice exam, you'll definitely be set for the exam. Your exam will not be longer. There will not be anything added to this practice exam. Some things will be taken away, or you'll be given choices or something like that. So this practice exam is like the sum total of the most you need to know, so to speak. Any little changes that might be made in your actual exam, any little changes, like I change a number here, or like I make something positive instead of negative. I shouldn't say little. Any specific changes you should look out for sure. You should be very careful and read your actual exam and make sure, that you see certain differences. There will be certain, but they'll be small. Seriously, your exam will be about 85%, or if not more, identical to the practice. So it's not about tricking you. It's just about maybe changing certain things to make sure that you're applying concepts, not just straight up memorizing. To be even more clear, wherever those changes may occur will be places where I feel I've given you a thorough solution and like every chance to really understand. Anywhere by the time you get the actual exam, like if there's any particular solution that I know I have not given you, or that I only superficially talked about or something like that, anywhere where I have not really provided you the answer to the original thing, then you can rest assured that that question will appear verbatim on your original thing. In other words, if I give you solutions and whatever solutions I give you, which we're about to talk about right now, whatever I fully solve for you, I reserve the right to slightly change so that, you're actually learning. But anywhere I didn't fully solve, if you're like, wait, he never exactly told us what to do here. If you get worried about that, at least know, okay, then I guess this is exactly the question that's going to appear on the real thing. So he's like not telling us because we're literally going to get the exact question. And then you still can go on the web and talk to each other, blah, 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 if that makes any sense. Now, and I will pause in a second to make sure it does, or to see what questions. Sorry, hold on, let me just change it. And of course, I was a little slow in getting up some recordings lately. I think we're all caught up with recordings, but for sure today, since we're going to talk about solutions, I guarantee you yes, it's being recorded now. It'll definitely be posted. Like, of all the classes ever to replay on a video, I would assume that you'd probably be the most interested in, you should use the video of any solutions we talk about, and you're allowed to use the video while you take the exam. Okay, again. But anything I leave a little vague or something, then, figure out on your own or with each other. But hold on, I'm just changing. Sorry. But what I hope you noticed, and this is a part, we're going to literally, I'm not breaking you up into groups today. I'm going to talk. I hope there's a lot of questions. I hope you stop me. I hope you guys are honest about what is clear and what's not, it's to your benefit. But I will mostly be talking because I know it's kind of I haven't for a couple of weeks, and I think I want to be as comprehensive as possible. But let me also say, before I take a breath, I just put it, I hope you see that just now, right before class, you got a document, you sort of got the preview of the notes for today. I hope maybe someone can confirm in your Google thing. I already put a big portion of the class notes of today, a big portion of the written out solutions. It's a big portion. It's not all of them. Oh, another person's here. Sorry. Hold on. But I want to make this very clear too. And this is maybe the most important. If you see, hello, Sonia. Good morning. Well, first of all, I'm sorry. Can anybody verify, confirm? Do you see it? Good morning. Thank you. Good morning. Awesome. Can anybody verify or confirm that? Do you see in your Google Stream from just about 5 minutes ago some lecture notes document that? This doc that yes. Okay. Thank you, Antonio. Totally appreciate it. Okay. And thank you also. Thank you, Antonio. Yes. Perfect. And thank you, Ajia. Okay. Oh, I never said hello to you, Ajia. Good morning. And tell me if I think I'm pronouncing your name right, but please tell me if I'm not. Oh, great. Thank you. Okay. Awesome. Thank you. Oh, yeah. So I want to be careful about this document that I just put in your stream. I rush in and put it, I put it there because I know some of you are kind of getting very anxious that you don't have it yet. And that, I want you to have it, but and there's more to come. It's not finished, but it's a big bulk. But I have to be super explicit if I can about one thing. And I know this is going to get me and other people in trouble. In the first part, the warm-ups, the part that frankly is a little bit less elaborate or challenging than some of the other parts in the exam. In the first part, what I tried to, in as detailed a way possible, really give you a model of what I'm looking for you to show me in your exam. I tried to write it all out the way I'm looking for you to do. You're not supposed to just give me answers, right? You have to show all your work. You really do. That's a big part of this exam. And I'll be, again, as detailed about that as I can. But if you're looking for a model or an example of how much does he really want? Well, first of all, the answer is as much as possible. The more you understand something, the more I want you to break down your understanding and show me every little step. And the less you understand something, it's to your benefit to show every step that you do understand, because I'll give you points for everything you show me. But if you're rocky on you want to show tons of work, and there's a way to show that work, givens first, a diagram, a clear statement of what the goal or the objective of the question is. And again, I'm going to say that as we're going through, but it turns out I'm very picky about this. Your goal in this exam is not to show answers. It's to show why the answers to the questions make sense in the universe and make sense to you. That's actually the hard part in a way. So in the first part of my solutions, I tried, even the bad handwriting, going fast, I tried to at least give you a model of what I'm looking for. I really want to see, here's the givens. Here's what the question is asking, determine, blah, right at the top, and a diagram. And whatever decisions you're making, I'm going to call this plus, and I'm going to call this minus, this direction minus, whatever. And then start showing your work, and then circle the final answer. You want to make the actual question and the final answer super explicit. And here's the catch. And again, this sort of physics 204 got into a little trouble with this. So I want to warn you again. Like your ultimate goal is to give me a document that is like a blue book in that you're not stapling the questions to the document. You're not cutting and pasting my questions to the document. You're just showing your work and your answers. But I need to be able to grade, to assess, to evaluate your document without, I shouldn't have to look at my old questions, the questions, or anything else in order to grade your document. It should be a self-sufficient, independent piece of physics. In other words, one of the hardest things I'm beginning to see for a lot of us is that in each question, in fact, let's just even turn to the first page just so I can show you what I'm saying. Like if you look at, so this is my first page of solutions. Okay, and I'm going to look in the chat in a second. I'm sorry, but let me just vomit this out. Like if this is, again, my handwriting is not perfect. A lot of you, once you get this model, you're going to do a much better job than I am of communicating your work. And it is about communicating your work. But if you look at the way I'm doing it here on the first page, notice that I'm making it super clear what problem I'm working on, like, part one, number one, the title, right? But then I'm not cutting and pasting the question in. What I'm doing is showing that I understand what the question is. I'm like, given y equals this, t equals that, and then it says determine what is v naught. Like, and then I changed colors. Like there's different, you can do different methods, and I'm not saying it's even perfect. Like it's not perfect. I actually think some of you are much better at this than I am once you know that this is what I'm asking you to do. But please notice that if I were going to grade this thing right here, I could pick it up and start, because you can assume I know physics, but don't assume I know the questions, right? I, as a person who knows physics, could just take this up and be like, oh, that's an interesting question, given that and that and that. Oh, and I see this diagram. Oh, the question is what's V naught? Oh, well, let's see what the student did. And then, here comes my work, right? I know it sounds really picky, but your goal is to give me solutions that I don't have to look anywhere else in order to just go good physics, oh, missing some physics here, oh, bad physics, oh, good physics, right? It should be self-contained. You are presenting the question to me in your words, and they can be quick. You can give me the minimal information I need to know, but don't rely on any assumption that I already remember the question or something like that. Because first of all, maybe I don't. But second of all, even if I do, the point is we're trying to do physics. We're not actually trying to just have a little exercise between me and you. We're not trying to have a private conversation. You're trying to write a document that could ultimately be passed to anybody else and shown them like, this is physics. And they could just read it and see, oh, like you could give it to Walters or Wu or whoever, and they'd be like, oh, I see the question. Okay. Oh yeah, no, they're not doing this right. Oh yes, they are doing this right. Okay. And that's a tricky business. I'm going to even tell. And I will shut up in a second. I always say that and I'm always lying, but what I'm really trying to get at is, if it's such a tricky business, and it's probably where a lot of people are going to lose points, is on this pickiness of mine. Like, I think a lot of you are going to know your physics or have answers, but where the grading comes in is how much are you really giving me a readable document of physics? It's almost like practice for getting to the place where we can do research and publish articles and stuff like that, right? Think of it as this is an article of physics that you're writing about how to solve these problems, which are real physics problems. So in the first part here, in my solution sample I'm giving you, I'm trying to drag it out as much as I can to give you a model of what I'm looking for. Don't just copy it verbatim, of course, for a variety of reasons, but use it as a model for what I'm looking for in the solutions. I have to warn you right now that because I do want to get you all the answers to this thing, and I want to get you all the correct answers and stuff. After the first part, you'll see it says, and I'll go back in a second and talk about my answers, but I do all this for the whole first part, for the first page of the exam, blah, 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 still in the first part. Okay, so here's my work. This is all just for the first part. And you might think some of this is overkill, but this is what I'm looking for. But then blah, blah. Now notice, right when I get to the second problem, again, I want to warn you, anybody who's not hearing this or never plays video is going to mess this up. Sadly, from here on, I'm sprinting through these solutions, and I'm just writing down whatever I need to write down to get you answers and get you correct answers. From here on in, don't do what I do what I say. From here on in, I'm giving you answers, not model solutions. And in fact, if I get more time, I'm going to go back and give you more solutions. I will, because I'm not trying to deprive you. But I'm saying like from here on in, I'm giving you answers so you can check if you're doing things right and stuff like that. But if you just literally verbatim copy the way I'm doing it into your actual test, that won't be good enough. And I will take off points. And then you'll be like, wait, but I did what you did. And so that's why I want to warn you. If you want to do what I'm doing, follow the model of the first part. From then on in, I'm giving you just bare bones. I'm kind of just giving you my brain in a way. And that like, and it might not even be very helpful in some cases. And that's why we're going to talk about them today and Wednesday. And even, wait, did we say the test is due Monday? I'm sorry. I keep saying that the test is due Monday. I'm sorry. I bet that's what's in the chat too. Sorry. I'll finish this thought and then go back to that thought. I'm saying, please, 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 if anybody's hearing me now, and I might have, if you hear me now, I'm saying, ultimately, when this document is finished and you have it, you'll have all the correct answers to this test. And if I make if I make a mistake in an answer, then that's my bad and I can't punish you for that. But from here, after part one, it's not good enough. Just like I will be looking for more from you than I'm actually giving you here. I want you to show me that you get how to actually solve problems. Okay, that's number one. I'm going to check again to make sure everybody heard that. But also, I just realized I've been saying something probably anxiety provoking. Let me back up. We post the exam this Thursday night, like I said. And then what I mean to say is it's due back right before class on Wednesday, like a week from this Wednesday. And if I put that wrong in the Google Classroom, I'll correct it. In other words, and I'm sorry to be confusing, and this isn't a postponement. This is just, this has always been true, but I'm just making a mistake. In other words, we're going to work on this. I'm going to try to guide you through the solutions today. I'm going to keep guiding you through the solutions on Wednesday of this week. Like we're not doing new material and we'll catch up. It's okay. And always remember too, even if we don't get to every single thing because it's on Zoom, I'm still your 204 teacher. So I'll know what we didn't get to and we'll catch up. Like it all comes out in the wash. But no, your exam will be due back on Wednesday of next week, which means when we come into class Monday of next week, the exam is still out there overhanging. You're still working on it. And I know that when we come in on Monday, the more work you've done on it or the more people have worked on it, even on Monday when we're together in class, even though the exam's still out there and it's still not due, even on Monday, you're allowed to ask me questions about the exam. And the more you've done on it, the better, your questions will benefit you. And the reason we do that is, God forbid, maybe something wasn't as clear as it should be in the exam, or maybe I made a mistake. And then we will learn that, like, if something's not, like, at worst, you'll ask me a question Monday and I might say, well, I can't fully answer that. I can't like give away the answer, but here's a hint, or let me clarify the question. Anything that's unclear in the questions, or you might even think, I think he made a mistake here, but I don't know. We can address all that Monday and you'll still have 2 days to correct the whole thing by Wednesday. So this is kind of why I do sort of expect like real comprehension and real thoroughness. And so if I've been saying it's due Monday, that's totally my bad. That's just me talking too fast. Once I will post it Thursday night, you'll have the full week to do it. And you'll even have Monday to come in and ask questions about it. So the more you can do before Monday, definitely to your benefit. Okay, I'm going to pause for a second. I know I'm saying a lot. And also please know, again, this solutions that we're going to start talking about today that I put in your thing, I'm not even done with them yet. I think there's a lot. It'll carry us for a while, trust, but you'll still have more I'll still get more to you. But now let me just look in the chat. I'm so sorry. Oh, okay. Oh, okay. There's nothing. And is someone in the waiting room? Oh, yeah. Hold on. This whole waiting room thing is so confusing. To everyone in waiting room, who's in the waiting room? Okay. If someone's there, if one of your friends is there and someone, I apologize. I'm getting mixed signals at West to whether someone is in the waiting room or not. But okay. So let me pause for a second. First of all, let me change the view to, let me just ask. First of all, backing up, I'm saying that the exam is posted, that the actual real exam will be posted this Thursday at before 8 p.m. and will be due back in class right before class, Wednesday of next week. That means the 21st. Can I just get a show of hands? Is that what you also think? And is that what it says in Google Classroom? Like, is that like everybody else? Is that your understanding, what I just said? Can I get any? Or am I contradicting something? Oh, I'm scared suddenly. Wait. Wait, first of all, you all can hear me, right? Wait. Okay, cool. Okay. Oh, okay. So I'm looking at the chat. So you can hear me. And yes, I'm saying, and thank you, Yasmin, and thank you, Molly and Aja and Amarani. Yes, I'm saying the exam is due next Wednesday. Can I ask this? Is that what you thought, or does it sound like I'm changing something again? Oh, okay. Thank you, Antonio. Okay. And so you understand, and I don't mean to be changing it again. I mean to be saying what I think I said all along. Okay, okay, Camilla, thank you. In fact, even I'm getting nervous. Let me just check. I believe this is also what it says in Google Classroom, but let me just absolutely make sure, just in case someone's not here or whatever. Hold on. Yeah, okay. This is what it says in Google Classroom also. So yeah, it's oh, I guess in Google Classroom it says it'll be posted no later than 8 p.m. this Friday. Now I'm saying Thursday. I'm not gonna. Well, it says no later than 8 p.m. this Friday. So if I happen to post it earlier, don't freak out. That just means you have that much more time. Like we'll get back to that issue. We can revisit. But okay, yes, the exam, just to be, I'm looking at the Google Classroom. What it says is what I'm saying, that once the exam is posted, it will be due no later than 10:50 a.m. next Wednesday. And one of the other reasons that I know I've confused things by postponing it, and I know I'm really super loose about a lot of things, and I am. I mean, and there's a lot of forgiveness. And also, we'll talk about if you do badly on this exam, there is recourse and stuff like that. Like, we'll talk about all that. But the one thing not to do is do not be late submitting this. You can be super late with homework. You can still hand in just about any homework that I've asked for, and especially those game things. You never have to apologize for being late on them. You're literally not late. There's no such thing. And same with regular homeworks. I'd rather you do it than do it on time or whatever. But with an exam, do not be late turning this in. And let me modify that further. Things happen. Of course, things happen, and especially in COVID. What I really mean to say is if you start detecting that something's happening in your life, if something's starting to look ugly and you're going to have a problem turning it in, communicate. You're allowed to text. You're allowed to, and I would recommend it if you're nervous, because I get to those faster. As long as you tell me what's going on, we can work it out. I'm not saying there aren't exceptions, but I am saying, and this did happen, what I'm about to say has happened even to like just last week at 204. Do not just radio silence and just like not show up that day and just like not turn in the exam and then just submit it like a day later because you feel like it and not say anything. You keep, like, that's not a good idea. If you have an issue, just communicate it with me as it's happening. Like, I'm going to have a problem turning this exam, and we will work together. But I do not want to be surprised that day by a missing document, and I blah blah. Okay, and again, you have to then come to class. If you're so freaked out and like exhausted by the time you come to class, and you have to jet out in the middle, fine. But you have to show up to class to show your colleagues that you obeyed the rules too. And I can also tell you that class won't be exhausted. You'll already be exhausted. We'll do something relaxing. It won't be hard to be in class. The hardest thing will be just to get the darn thing in on time and step up and show your face. No, wait, let me look in chat again. Sorry. Right, it was. Oh, yes. Okay. So thank you for your honesty, Yasmin and Camilla. And again, no, I postponed it. Right. It would have been due this Wednesday. The exam would have been due this Wednesday, but then that would have mean I had to have posted it for you guys last week, which I didn't. And the reason I didn't is because I didn't get you enough solutions in time. I want you to have full solutions before you do that. So we did postpone it a week, and I'm sorry if that, and I didn't, and that confused somebody else over the weekend too. It was postponed. Now, whatever it says in Google Classroom is correct. You refer to that. We're going to start going over solutions today. So I apologize if there was confusion. So one good news about all of this is no one's, even if you did miss class, like everybody still has a chance to do really well. Like nobody missed any other quiz or something like that. Okay. We're going to start talking about solutions if that's cool. Okay. And I'm not trying to scare anybody. The truth is, what I really want this exam experience to be is intense. Like I want you to intensely learn your physics, but I'm trying to reduce distracting stress. So again, let me say, it's absolutely true that once you get this thing posted on Thursday, and once you see it, first of all, you're not going to be surprised. You're not going to be like, oh my God. You're going to be like, yeah, that's what I thought, because it's going to be very much like the thing we're going over. Okay. And yes, you're allowed to you're allowed to do anything you could possibly think of as cheating, you can do, and it's therefore not cheating because everybody can do it. But if that sounds like a gift, or if that sounds like I'm a sucker or whatever, like maybe I am, but let me just warn you, even though you'll have full solutions and at some level, some of you are going to be copying stuff from here, copying, the standard of grading is, first of all, you got to give me a full comprehensive document that goes through all steps that I never have to look at anything else to grade, right? That's how much work you have to show. Like you know, from beginning to end, you have to make it clear what's going on. But furthermore, you can learn everything from your friend, even while you're taking the exam. You can learn everything from Khan Academy while you're taking the exam. You can learn everything from my past videos. That would be my nice, you know, that'd be so flattering. Please like and subscribe. But you can literally do that. And you can even think that you're like pulling one over me while you do it, but you could literally sit there with your solutions to the practice and two YouTube videos on and a friend next to you while you're writing things down. But here's the deal, and I'll look in the chat in a second. Here's the deal. With all that help, that's supposed to go in your brain to get you to understand things, even if it's at the last minute. But by the time your pen hits paper, you don't have to give credit to anybody else or anything like that, but you cannot write down something that you don't understand. The reason you cannot write down something that you don't understand is that I promise you, I'll know it if you do. And you will lose points. Like you have to, idea is by the time you're writing everything down, you're showing what you now personally understand. And the really weird thing about this method, it sounds like I'm saying you fully cheat. It's like, it sounds like a joke, but just to be clear, one of the reasons I love doing it this way, I'm now convinced. We just had a physics 204 exam done exactly this way. And just so you all know, 2 sections of 204, and I'm not saying this critically of them, I think they did great and all that, but just so you know, in 2 sections of 204, where they had fully opened everything, and they've done this before, the mean score in one section was a 77 and the other was a 71. Like it really is possible to get grades like 71 and 77, even when you have all the answers sitting in front of you. Those were the means. And the standard deviation was like 10. And I don't know if you all know what that means. In one class it was like 10.2, and the other one, I think it was 9 point something. You might not know what that means, but what in effect that means is the grades were super spread out. It wasn't just, not only was the average grade like a 71, which is not even a bad grade, by the way, it's probably an appropriate grade for a physics first midterm. And by the way, if the average was a 71 and you got a 71, it doesn't mean you're getting a C in the class. It probably means, especially if you're doing your homework and everything, and if nothing ever changed, you're probably already getting like a B minus or a B. But, and labs, so you're probably getting like a B plus. Like if you got a 71, you shouldn't even freak out. But what I am saying is, make no mistake, even with a fully open source exam, the mean was like a 71, and to say that the standard deviation was a 10 means it's not even like everybody got a 71 because of some weird grading method I had where I just knocked off points. The grades were all over the place, even though everybody had the answers. That is not a criticism. It's just like a caution that this isn't, you want to think of this exam as like writing an essay where you're trying to make sense to me and show me how much better and more articulate you're getting at the language of physics. It's not about showing me that you have the right answer. I know you have the right answer because I gave it to you. It's about showing me that you get why the right answer is the right answer. That's all, like my big warning, We're going to start talking about it. Let me just look in the chat. Sorry. Okay, when we write out, oh, this looks like a good question. Okay, Molly's question. When we write out the equations for the test, are we also expected to define each part of the equation? Okay, that's a fair question. If I'm understanding that, oh wait, let me look at it as part of the work, right? Well, okay, here's my simplest answer to that. I mean, because again, this is all fine to, you know, I know this is tricky, nuanced business. And so my simplest answer is, let's say Molly had that question in her mind Tuesday night when it was too late to ask me. Let's say she's writing things out and suddenly that occurs to me, like, oh my God, does he want this? And if she can't reach me by then or whatever, the safest answer is, when in doubt, show more, not less. if it even occurs to Molly, oh, maybe I should define each part of the equation, do it. Because there's no way you're going to run a risk. You might take an extra minute to do it. But the more you show me, the more points you're getting. And the truth of the matter is, if you show me a lot, like on the first page, like you actually take the time to define each part, then I'll probably even unconsciously be more generous on the second page when I'm grading, once I already see that you really are walking the walk. So first of all, when in doubt, if you have a question like that, do the thing that comes to your mind. If you're like, I wonder if I need to do this, then assume yes. Now, to be a little bit more specific, I'm not sure. Like if you write down like V bar equals X minus X naught over T, I'm not saying you then have to now go in English and write V bar stands for average velocity, X stands for displacement. You don't have to do that. You don't actually have to. I'm saying, if that's literally what you mean, because again, here's the other, like when in doubt, one, do more, not less, but also when in doubt, if you're running out of time or this or that, another way to think about the answer to these questions is you cannot assume that I know the question, that the reader knows the question, but you can assume that the reader knows physics. You are writing a physics document for another physics person as though you were submitting it to a journal. So once you write down an equation, no, you can assume that I know that equation, sure. Or you can assume that I know that A means acceleration. So you don't have to go that crazy. But certainly if there's any, for example, say V naught means initial velocity, you don't have to write those words for me because I know that. But you certainly should make the extra effort to be this means velocity at over here, or when the clock, define everything for the context of the problem, but you don't have to back up and define physics terms themselves. And that's nuanced. I'm going to say again, it's a totally legitimate question, and we're here to answer questions like that. In the final analysis, when you sit down to take to write out your exam, if most of your stress is about sort of what is he exactly, how should I present this? Then you're stressing about the right things. If most of your questions in your mind are like Molly's, then that's good, because it means you really are worrying about the right things. And this is nuance. This is the art of science. This takes a while to learn. Again, it's not just for me. This is practice what it means being a researcher, publishing articles, blah, or books or whatever, blah, blah. So many of you won't get this right the first time, and it's okay. I should also rush to say that in 204, they got these grades back. I actually think the grades were fine, what they should be. I was actually proud of them. But believe me, they were giving an opportunity to do test corrections to get some points back. They do get, and we did another assignment, so they got points back. Nothing is your last chance. There's no last chance here. It's all a work in progress. So we're learning how to do this. You can even think of this midterm as your first practice as to how to take the final. And there's cushions along the way. So don't freak, but yeah, but yes, that's what, in the end, you're going to find that where a lot of you lose points is probably places you didn't expect. It's not going to be because of wrong answers. It's going to be because I say, no, you didn't explain this clearly enough or something like that. Okay, let me just go to the next. Sorry. And okay, I'm going to answer Jitlali's question in a second, but I see Molly had a follow-up. Right. No. It's a very good question. Molly's question is a very good one. And again, why I say it's a good one is it's not totally easy to answer. It's a little bit easier to see and experience, but it is kind of what we're here for. Let me turn it one other way. Yeah, your job is to break down the thoughts into as tiny steps as you can. So part of my goal is even to get Molly or whomever even to think about a thing like that. Most of us think in steps that are way bigger than we should in life and in science. One of the secret tricks of science is to break down. We call it grain size. How smaller are our grains of sand that are making up the whole beach? Anytime you could even conceive, if you could even picture, oh, I bet I thought that was a step, but I could break it into two. I thought, I used to get solutions from people a long time ago where they'd write down the question, then they'd write down some equation or something, and then they would literally write algebra. They would write the word algebra or math. They'd be then I did math and then I got this. And I was wait, it's not a step to say that you then did math. The point is show me the math. Otherwise you might as well just write, then I did physics and then go to the answer. clearly that's too big. You got to break that down further. But then what does that mean? Like you write down the equation. If you divide both sides by 2 in your head, because like you're good at algebra and you just divide both sides by 2 in your head, pause for a second, be like, oh, I just divided both sides by 2 in my head. Even though I'm such a badass that I did that, and even though I hope he knows I'm so smart that I can do that. No, I don't know how. I can't read your brain. So if you divided both sides by 2, put it down. You'll never get points taken off for putting down too much. The only reason not to put too much is because you're running out of time or something, or you're actually starting to realize that you don't understand the steps. Well, that's the point of all this. Like the minute you could see, and that's why I want to go back to, even though I'm saying, this is why I love Molly's question in a way. Even though I'm saying that actually technically what she's asking, I'm saying she doesn't actually have to do, the minute it occurred to her, if I'm not there to answer that, then just do it. If you can conceive of how you could show another step, show the step. There's no harm. It's only good. Okay, now let me go back to, Sojit Lali's question. How many questions will be on the midterm? Well, okay, so again, the simplest answer is it will be just like the practice midterm. And the practice midterm had, I believe, 5 parts. I think it was 5 in each, 5 parts, and then each were divided into multi sub parts. I can't even remember. I think it was 5. So the simple answer is whatever's on the practice midterm is the answer. But and it really will. Again, it's going to look just like that. And you're going to be given the same equations on the first page, all that. Like the format will be just like the practice midterm. Yet it will be shorter. So if the practice midterm had 5 part, like Roman numeral 1, 2, 3, 4, 5, I think, then your actual test, at worst, I'll present those exact same parts, but I'll say like, you must do part 1, you must do part 2, but you have a choice between doing 3 and 4 or something, or I'll literally move one part. It'll be no more problems than the practice, but it will be less. So I think, so in other words, if the practice midterm was 5, I think your actual exam will be 4. Big problems with multi-parts. That's the best thing I can say about that. And then Molly, okay, is this making sense so far? I hope. Okay, what I'm going to do for a second, I'm going to start walking through some of the solutions in a moment. Again, we're going to keep walking through them on Wednesday. You have no other homework but to like deal with this, over the next week. Of course, any homework you can catch up on, please keep coming. In the game things still. So I'm going to start talking. I'm going to walk away for like 2 minutes, frankly, to use the restroom. Okay. But also just start flipping through and look at what I'm doing here to get a sense. Okay. And then I'll start talking and see if you have any questions or concerns. Also, again, I cut off right at I do part 1, then part 2, I very quickly give you an answer. And believe me, I know that part 2, I did not make it clear how I got that answer. I will talk about that, but the answer is definitely right for the river problem. Then part 3, I start solving, but I didn't even get to the end yet. And I know that, so don't freak, like you're not missing anything, but there's enough for us to talk about here before I even get there. And you will get all the rest. Okay, so I'm going to take a break for a second. Please look to see if you have any questions or whatnot, or if there's anything. So I'll be right back. Okay. So again, just to be as clear as I can, I'm about to start like walking through the solutions with you. You will, by the end, have fully written out stuff for everything, but we're not, today I'm going to just talk from the beginning and keep going, but it is a long exam. So I'm not, even with today and with Wednesday, I may not necessarily be able to like literally go to every single part. So the more we get into this and the more you're looking at home, the more you're going to have to start guiding me on Wednesday on what you really need to hear me talk about and what you don't. Like you'll have it all written in one way or another, but we're just going to, so we're going to build momentum today. I'm about to start in a second, but is everybody clear? Can I just get a show of hands that we're clear on what's happening? Like, are we clear on? Thank you, Molly. Totally appreciate it. And thank you, Alyssa. Thank you, Luna. That was fast. Thank you, Lolly. Thank you. Thank you, Alyssa. Thank you, Marani. Thank you, Camilla. Okay. Also, thank you, Antonio. Thank you. I love this part. I don't know why. Thank you. Wait, who did I miss? But thank you. I totally appreciate it. Oh, and then you put your hands down. That's cool. Okay. 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 So I'm going to flip back to the beginning. And again, well, I can say the exam gets harder and harder as it goes. The beginning is not as hard as the end. I'm going to over talk the beginning again because it's the same thing with this class. This is how it works. We're really into fundamentals here. We beat the fundamentals like a dead horse, and it drives people crazy sometimes. Like I spend a lot of time on the supposedly easier stuff, and then everything starts accelerating, especially in physics 204. But the reason for that is the idea that if you really, really know your fundamentals, then even harder things get easier and easier for you. Like it's about learning how to do this on your own. So forgive, but I am aware that the beginning, like if I'm talking here and all of you are like, yeah, we totally get that. You can private chat me and say, can you please speed up? Or can you please skip that? Like I won't be insulted. But all right, so I'm going to the beginning. I'm also hoping I'm going to talk about these solutions that are up here on the screen. I made them so that I'm not going to be looking at the questions while I say it, because that's the idea. But certainly you might want to have the questions out in front of you, like, and make sure that I'm, whatever. You might want to have the questions in front of you. Okay, hold on. I'm just changing one thing and then we go. Okay. All right. So the first question, purple plushie. So you're standing on this building. The building is 20 meters high. You're told that this purple plushie thing is thrown down off the top of you're told, I believe, and you should check, but I believe you're told not only that it's thrown, but it's literally thrown down. So thrown means it's not dropped. It is thrown, thrusted. Okay. You're told that. You're told that it takes 1.8 seconds for this purple plushie to reach the ground from the top of a building. You're somehow, I probably should have made it more explicit, but this is a normal everyday building on planet Earth. Like there's no tricks. So we're on planet Earth. This is an example of free fall. So we're going to, so the English tells us enough to know we're going to assume that once this thing is in motion, once it's left our hand, it is now in free fall, which means the only influence acting on this object is the gravitational pull from planet Earth. And note, please, the fact that we threw it does not change that fact. Even if we had thrown it up, even if it was going up, like there was one homework assignment, I think, or maybe there hasn't been yet, called free falling up. Like even if it was going up, we would still call that free fall. Or even if it was going to the side, we would call it free fall, no matter what our initial contact with our hand and the ball was, the plushie. Once it was released from our hand, nothing is touching this object, nothing is affecting it, not even wind, only gravity. So that's called free fall. So what we know is that it will accelerate at a constant rate. That's what I mean by A equals A naught. Like that's a given just from the English of the problem. It's a given that there will be an acceleration which will be constant and which will be approximately, hold on. Which will be approximately 10 meters per second squared. It should say squared. I'm appalled at myself okay. That does not say that in the problem. What it just says is like it's a building on Earth. So I know that there'll be free fall acceleration of 9.8, which I'm allowed always to round to 10 in any of these kind of problems. Notice too, though, that I'm just saying that the value of it is 10, like because it's free fall. I'm not saying whether it's negative or positive or anything like that at that moment. I'm just saying I know it's 10 and I know it won't change. Okay, and the question is determine what V naught is. So what do? I make my little diagram, but then notice I make a decision. I literally say, let, I make a little coordinate system. This is where sort of Galileo comes in. I make, and notice now I'm in blue, like now this is my work, so to speak, solving the thing. I say, let this be my coordinate system. Let up be designated negative and let down be designated positive. That is a decision that I'm making as a problem solver. The problem didn't require me or tell me to do that. And it's a choice. Like, and I'll tell you why I made that choice in a second. But note, if you don't like that, if you're like, he made down positive, what is he, psycho? If you like making down negative, you can do that. You absolutely could start with let down be negative and up be positive. And if you stay consistent with that, you too will solve the problem correctly and it'll all work out okay, because that's Galileo. So why did I do the other way? Well, first of all, I'm going to show you, I think it's more convenient and easier to do it my way. I think if you make down negative, it's going to get annoying because everything in this problem is going down. Like gravity points down, like the acceleration due to gravity points down, and the darn thing is falling down. And apparently you actually threw it, like you shoved it down. So if you make down negative, you're going to have a lot of negative signs to deal with. If you're careful, they'll cancel out properly and all be fine. But it's like a lot of mess to deal with. So I'm making the choice to say if something's always going down, if everything's going down, I'm going to call down positive so I don't have to deal with all these negative signs. You can make whichever choice you want, but you must make a choice. Like literally, you have to put this in your solution, right? You have to get in the habit of right away making choices about coordinate systems, about what reference frame you're in. Okay, but so I made that choice. You can make a different one, but if you don't make any, I will take off points. Or especially if you inconsistent, make one and then you're inconsistent with it. But okay, so I made that choice. Here's my diagram. It's given that a equals g and that t equals 1.8. Oh, and I even also say, notice, please, sorry, to the left, like over here, I say let y naught equals 0. What I'm trying to say, like kind of badly, and you might assume this is true, but you have to be explicit. I'm saying, okay, what are we calling? We're calling this direction negative, we're calling that direction positive, and the 0, the origin of our coordinate system, is the top of the building. You might think that's obvious, but a lot of people might think it's obvious to make the bottom of the building 0. And either one could work if you're careful, but you got to know these choices that you're making. Okay. So I say the top of the building is 0. The building is 20 meters high. Then notice now, then with my coordinate system with down being positive, I'm thinking if this thing's going to fall 20 meters, that means 20 positive meters because down is positive, right? Like that's my point. All right, so I go to the next page. All right, so here we go. And again, I'm dragging it out, but you should drag it out too. Now I write the equation. I'm a physicist, so I can read this. I know this equation, and you know it's in the front of the sheet. So like Molly's point, like you don't literally have to say, okay, A means acceleration or something like that. But notice I am being a little bit clear, like, okay, the equation is y minus y naught, like displacement equals 1/2 at squared plus v naught t. Y naught I called 0, so cross that out. So we have y equals 1/2 at squared plus v naught t, right? Okay, and now here comes something. What a lot of you might do right now is just start plugging in numbers, and that is okay. That is okay. You might start plugging in numbers right now and start churning and burning. And if you do that carefully and explicitly and you get your answer, I won't take off points if you plug in numbers earlier than I do. I won't. But I will tell you as a strategy, and especially as we start getting into physics 204 or whatnot, it's a really good habit to start developing now to plug in your numbers as late as possible. It will make things look confusing to some of you at first, but it's a long-term better habit. So that's what I'm doing to show you the habit. So and the reason for that is right now I'm doing physics. If I don't want to if I accidentally put in the wrong numbers too early and then they're wrong, then like lots of points are going to get taken off. And I just, in case I make a calculation error, I don't want that to infect my physics thinking right now. So I write down y equals 1/2 at squared plus v naught t. The problem's asking us to look for v naught, right? So I do algebra now. You know, I would subtract 1/2 at squared from both sides. So then I've got v naught on the left side. You know, what do you call it? I'm isolating I'm solving for v naught. So then I divide both sides by t. So now I have this thing that's looking complicated. I'm here now I'm right here. like I'm here. Now, I have this complicated thing. I want to pause there too. If you look at that, somebody might be like, whoa, wait, is that an equation we're supposed to know? Or like, what the heck is that? It's not an equation you're supposed to know. It's actually, it is always as true as it's just a reformation of the equation you do know. I'm not saying you have to memorize that or that that's a formula. I didn't get that from anywhere. It's just a rearrangement of what you know, right? And it looks complicated because it is, but it's just part of the work. And you just wouldn't notice how complicated it look if you'd already plugged in your numbers, which is why some of you will just plug in the numbers right. But that gets into other problems. Okay, so I have that, whatever. So I have that thing. So now, because I've got V naught isolated by itself, the thing that I'm trying to solve for, now I can plug in numbers. Now it's like an computational problem. So I plug in. So notice what I plug in though. So I'm here now. I plug in 20 for y. I don't plug in negative 20. I plug in 20 because I'm explicitly calling down positive. If you call down negative, you would have to plug in negative 20 there because the displacement was down, right? Okay, 20 minus 1/2. Now I put in 10 for a. 10 as in a rounding version of 9.8, like that's the gravity number, but notice that's positive. A lot of us may often think, oh, I know the acceleration due to gravity is like negative 9.8. No, the acceleration due to gravity is 9.8 or 10 pointing down. Whether you call down negative or positive is a choice that we make for every individual problem. So I'm putting in positive 10 for gravity because gravity is pointing in the same direction as the displacement in this case. Yeah, okay. So I put in 10 for that. And then I put in 1.8 for the time squared, okay, and divide the whole thing by time. So I'm just like plugging into this like equation that we in effect just made up or just discovered. Okay, so I plug in, I do the math and computations. And now in the right down here, after I do the computations, I get 2.11. Let me also pause here and say, if you follow my method of postponing the numbers as long as possible, then the thing is, if you did all this whole page correct and did all this physics correct and clearly, and even here too, you can put the same way I'm making comments as I go and like making these little brown marks. Like I don't want to mark this whole thing up and make it really messy. Oh, I guess you already have it, so it wouldn't matter if I did. But you, every time I'm saying, oh, notice this, think of that as an opportunity you could write down in a different color. You can comment. You should comment in English on the work as you're going. I'm probably not even doing that enough here. You could like literally divide your whole page into 2 columns and have one for the work and one for comments. That would be brilliant. Actually, it'd be awesome. Or 2 colors or whatever. But the thing is, if I did all of this way, the way I'm saying, or if you do this way and you postpone the numbers for the end, the great news is if you mess up the calculation, if like you use your calculator wrong or you forget to square or something, I'm going to take off like 1 point, at most 2. If it's just a computational error, that is not a big deal. That means you still know your physics. I'll take off 1 or 2 points. But if you plug in the numbers first and then things are getting all fouled up and I can't even tell if you know your physics or not, you might lose more points. So it's just like a safer thing to separate your physics from your computations. We're not here to learn how to add and subtract. We're sort of hoping we know how to do it. But if you make mistakes with adding and subtraction, that's to take up with your math teacher and your priest. Like, you know what I'm saying? Or your imam, whatever. So 2.1 I get, 2.11. And by the way, I don't think if I rounded there, then I should make that an approximate equal sign. But I think it was exactly 2.11. So now my final answer that I was looking for was V naught, the initial velocity was 2.11. Notice I got a positive number. So I stop and look at it in my mind before I even circle it. And I'm like, positive number. Is that right? And then I think, wait, but the initial thing was supposed to be down. Maybe should I be getting a negative number because it was thrown down? But then I remember, oh no, I made down positive. So positive is good. It should be a positive number because I'm looking for a downward speed. So I circle my final answer and say it was thrown at 2.11 meters per second down. And that's the answer. Okay. So I know I talked a lot about, I know it's not the hardest problem in the world, but that is the first problem. I'm going to pause for a second. Are there any questions or any concerns about that? Fantastic. Thank you, Molly. That's great. And that's a good, thank you. All right, good. And thank you, Antonio. Great. I totally appreciate it. And totally put those in the, what do you call it? Totally submit those for participation points. Thank you. That's it. All right. So I'm going to go to the next one. Excuse me. And again, I'm over talking the easy ones because it's easier to see in the easy ones how to actually think, right? Like the whole goal of physics is when you actually think you can do something in your head and you think something is easy, take a movie of what you did in your head and then slow down that movie and stare at it. That's how you learn how to do things that you don't know how to do. Like when you do something and you think it's easy, really investigate what the heck just happened in your mind to make it so easy. And then that way, when you get to hard things, you play that movie again. You always use the same model for hard things as you did for easy things. And then the hard things become easier. But all right, so now the next problem, chopper, kind of a similar situation in that we're above the surface of the earth. We're going to assume that anything in free fall is going to experience gravitational constant acceleration. But what we have here in this situation now is we have a helicopter that's holding a package, and the helicopter, we're told, is accelerating up at 5 meters per second squared. So the helicopter is not in free fall. The helicopter is in effect being pushed by something. Now, what is it being pushed? Oops, sorry, someone's here. Sorry. Oh, wait. Oh, and I see we're almost at 12:05. I think the person that's here is from the other class. Yeah, I don't think she wants to be here yet. But I see the time, and again, I know I'm going slow right now, or I'll keep going with this on Wednesday, and blah blah blah. But here, what a helicopter does is it has blades that push down on the air. And then by something called Newton's third law, which we're going to get to soon, the air pushes up on the blades. And so the helicopter goes up. The helicopter is not free falling. I hope it's clear. And a helicopter, by the way, people don't realize how powerful air really is. A helicopter would not work in outer space. Like literally it would not work. It needs air, just like an airplane needs air to go up. So the helicopter is not in free fall. The helicopter is accelerating up at 5, but then at some moment it drops this package. It drops a package. The package is released from it. The package does not have propeller blades on it or anything. So the package begins to free fall. Now, I don't know if it's moving down or moving up, but it is free falling in the sense that nothing is affecting it other than gravity. So here we have a situation. It's going to be a little bit more complicated than the last one. Now we have like 2 objects, and one of them is going up and one of them is going down. So now I have to deal with 2 different directions. So now I am going to have minus signs somewhere. I can't avoid them. So now I'm going to make the choice, okay, since there's going to be minus signs somewhere, I'll call up positive and down negative. So I'm making a different choice than I did in the last one as a user, as a problem solver in blue. Follow me? The important thing is to explicitly make a choice each time. So I'm going to call up positive, I'm going to call down negative. And what I'm told is that the package is released. It's not thrusted at any kind of speed. It's released from the helicopter, and at that moment that happens, the helicopter is accelerating up at 5, and I'm going to call that positive because I'm calling up positive, and it's moving up at 20. We're told, like, the helicopter happens to have a speed and an acceleration. Of course, those are 2 different ideas, right? So at this moment, the helicopter is moving up at 20, holding a package, and it's accelerating at 5, and then it releases the package. So just to be as clear as I can, at that moment of release, both the helicopter and the package are both going up at 20, right? Like so this is equivalent to someone standing on a building and throwing up a package at 20. At the moment the package is released, it's like stationary relative to the helicopter, but it ain't stationary relative to the ground, if you see what I mean. So it's almost like so it's either like you just throwing up something off a building, or if you don't like that, imagine yourself jumping off a building and letting something go. At the moment you let it go, it is moving up, but it's not touching your hand anymore. So the package will be accelerating down at 10 meters per second squared. Again, I didn't put in minus signs yet or anything in the brown because I hadn't made a decision about plus and minus yet in the brown color. But at the moment this thing happens, the helicopter continues to upwardly accelerate at 5 because it's a helicopter. It's designed to do that. The package is now going to accelerate down at 10, but both from that same spot and both from that same initial velocity of 20. And our goal here, or what is the point of the problem, determine what's the difference between the two 4 seconds later. Like, how far apart are they? What's the difference between the two positions? In other words, how far did the helicopter get minus how far did the package get? That's what we're looking for, if that, I hope, makes sense. Okay, so my method is going to be that I'm going to independently find out how, I'm going to just like treat it as two different things. I'm going to figure out how far the helicopter got with that information. I'm going to figure out how far the package fell down or whatever, and then I'm going to like subtract. And by the way, if the helicopter does go up some amount, and if the package goes down, which you might expect, maybe I'm going to subtract the two because I'm looking for a difference, but it's going to be like this minus that. And if that happens to have a negative sign, then I better be careful about that. So it'll be like a minus minus. I mean, not to, right? But we're going to get the difference between the two, regardless of what the numbers or the signs are. We're looking for the difference. All right, so I go to the next page, and this will be the last thing we do today, of course, because we have like 4 minutes. So I go to the next page. Okay, I'll look at the helicopter first. Okay. Oh, and I'm going to assume that where this whole thing happened, we call y naught equals 0. Okay, so so I'm right here right now. So the helicopter, 1/2 at squared plus v naught t, same equation. The helicopter accelerates up at 5, so I'll call that positive 5, right? 1, and it does so for 4 seconds, so 4 squared plus 20 times 4. Like, the helicopter didn't start from rest. Like, even when the clock started on this whole problem, the helicopter already had 20 units of speed. So, okay, so I solve and I get that the helicopter in that time went up 120 meters. Okay, now I look at the package. And again, this is where we're going to end in 2 minutes, but this is definitely worth looking at. I'm just being careful. I'm just following my method. But now I look at the package. Okay, I put in, for its acceleration, I put in -10 because the package is now free falling. It's accelerating down. Okay, times 4 seconds squared. But then I do say plus 20 times 4. Like, please note, the package began with speed, not speed relative to the helicopter. The speed relative to the helicopter might have been 0, but since the helicopter, I think you see my point. The package, it's being thrust up while accelerating down. That is not a contradiction. It's part of the issue of physics, is that acceleration and velocity are two different things. You can be velocitizing up while you accelerate down. And what does that mean in English? It means this package is going to go up before it comes down. It's going to be slowing down while it goes up. The package is. The helicopter is going up while speeding up. This package is going to go up for a little while slowing down. It's going to go up before it comes down because it was thrust up. It's not a cartoon. It's not going to instantaneously turn around. So what this seems to imply, if you look at it, is the package gets nowhere in 4 seconds. I think that's a little bit of a surprise, maybe. It's not a mistake. It's part of the point of the problem. The displacement of the package in 4 seconds is 0, because in English, what actually happens is the package goes up for 2 seconds, and in those 2 seconds, it covers 80 meters, and then it comes down for 2 seconds and falls back down the 80 meters. Are you supposed to have known that? Not those details, neither did I. I didn't see them until I did the calculation. But you do. But if you think about it, we have something that is thrown up at 20. Those drills and chills that we were practicing in our head, think about it. If something's just thrown up at 20 and it's losing 10 every second, then it'll be 20, 10, 0. Like, it'll take 2 seconds to get up, and then it'll start falling down. And 2 seconds, and there's 2 more seconds for falling, because it's a total of 4 here. So in those 2 seconds, it'll fall right back down to the same place it went up in 2 seconds, because gravity acceleration is constant. So literally, and this is where we'll stop, the helicopter goes up 120 meters. The package goes nowhere in that time. Like, its distance might be, but its displacement is nothing. So in the end, so that's why I haven't read explain. Like, you better explain that. But then the final answer is 120 minus 0, which is 120. And that's the final answer of the problem. And I know it's 12:05. So we're going to stop right now. We'll keep to, please just keep work. I will give you more. There's more in this packet. I'll give you more. Please just keep working however you want. Blah, blah, blah. Can I just get some kind of quick goodbye or something just so I know we're okay? Thank you. You too. Great. Have a great day. Great. Thank you. Awesome. Thank you. You're the best. Okay. Goodbye. Goodbye. Bye. 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 Okay. Bye. Bye. Have a great day. Yes, you too. Thank you. Have a great day. How are you doing? Fantastic. Thank you. Bye. Bye. Bye, Luna. Bye, Aja. Bye, Yasmin. Thank you guys so much. I hope you see that I'm saying goodbye because I'm going to run to the next class.